All right. So think of this as f of x, right? Y equals f of x. So when I plug in, or when I look at the change in sign, so I start at the front here and make sure it's in the proper order. You wouldn't want this 2 in front of the x cubed. You want it in the proper order. And I look to see how many changes in sign there are. What I mean by that is you look at the coefficient. This is 1. That's positive. The next one in line is negative. So going from here to here, there's 1 sign change. Okay. And then here, going from negative to positive, there's another sign change. So there are a total of 2 sign changes. And Descartes' rule of sign says that if in your function, if you have 2 sign changes, then you could have 2 positive real zeros or 0. In other words, you start with the highest number is the number of sign changes. So I'm going to make a chart here so you can see. So we have plus, we're looking at plus, and we're looking at minus, and then you could also have imaginary and total number of zeros. Now, because this is a degree 3 polynomial, I already said that the total number of zeros is 3, okay? Now, by Descartes' rule of signs, because there were 2 sign changes, we went from positive to negative, and then we went from negative to positive. That's 2 times. I have that 2, and then you subtract, you go down by even numbers. So it could be less than 2. So it can't be 1 because you have to go down by an even number. So the next even number down is 0, okay? So there are either 2 positive root zeros or 0 positive zeros. Those are the 2 possibilities. Now let's try negative. If you're testing for negative, you want to look at f of minus x. So I'm going to plug in a negative x into my polynomial, and I get negative x cubed. Now I plug in negative x here. That's minus 3 times negative x, and then plus 2. And I simplify this. If you cube a negative, it's still negative. So this becomes negative x cubed. Here, the double negative is positive, 3x, and then we have positive 2, okay? Now, notice there's only 1 sign change, okay? So if you go here, you go from negative to positive, that's 1. But here, from it's positive, there's no sign change. From positive to positive is no sign change. So there's only 1 sign change. So we have 2 possible positive zeros and only 1 possible negative. And if you subtract 2 from 1, you get a negative number. So you can't subtract 2. So here we could subtract 2 to get 0, but here we can't. So it's either 2 and 1 or 0 and 1. But remember, the total has to add up to 3. So 2 plus 1 is 3. So this is 0 here. These 3 numbers have to add up to this number here. Okay. Just kind of put a line there to separate that. And think of that as an equal line. 0 and 1, well, in order for it to add up to 3, I have to have a 2 here. Okay. So these are the only 2 possibilities according to Descartes' rule of signs. Now we know the zeros already. We know that this is the correct situation because the 2 positive zeros are the 1. So in other words, x minus 1. Now, remember I said it has multiplicity 2 because of the way it's factored, and you have that square on there. Okay, so someone's asking me about that. Where did I get the x minus 1 times x minus 1? So let me show you. Let me go back to that. That's a good question. And since we're talking about that right now. So here, I found that when I use synthetic division, since this is a 1, I'm dividing by this factor. And what I got was, from this comes the x minus 1, and then these coefficients, so this is 1 and 1 times x squared plus 1 times x minus 2. And this is a quadratic function, so I just factored it. You know, the reverse of the FOIL, where you can use the AC method, you're just factoring this. So I factored that just like you factor a quadratic function, and I got x plus 2 times x minus 1. And you can see if you FOIL this, you'll get this function right here. And then I noticed, oh, there are 2 of them. So that's why I have this square here. And that 2 is the same 2 that is in my little chart here that I just did. Where is it? I lost it. Okay, here. Okay. This says I have 2 positive zeros. Well, actually, I have 1 is my 0, but it occurs twice in the factorization. So it has a multiplicity of 2. So that's what that comes from. And then it said that I have 1 negative real 0, and that would be the other one, which is coming from this. So negative 2 is also a 0, right? Because if you set this equal to 0, your solution to that is x plus 2 equals 0, is that x has to be negative 2 in order to make this 0. So negative 2 is the other real 0 that occurs in, sorry, I'm shuffling pages here, right here. So this is the correct situation that we have. Descartes' rule of sign says it's either this or this. It's kind of like limiting the possibilities so you can kind of narrow in on it.